can be a supernova. And only a star at least 5 times bigger than Sun become a supernova. 5 times, it's the information that I found. 5 times bigger than Sun can be a supernova. The smaller stars go to another way that we will see in the next stage. And the explosion expels all the material of a star at a velocity of 3,000 kilometers per second.
Mm-hmm.
The velocity, and all the materials inside the stars goes to the universe. But how a supernova happens? To understand how it happens, it's necessary to know how a star is formed, because the supernova is an explosion of a big star. So the first stage of a star is the nebula. I don't know if the name is correct.
Nebula?
Nebula. It's a cloud of gases and dust. It's the start of the star, the beginning of the star. It's only a cloud. So the next stage, the second stage, is the main sequence star. It's the sky like we can see, the small stars, and the name is a baby protostars. It's the star, the stage that we see in the sky, the night. So the third stage is the red giant. After billions of years, a star at the end of its life becomes a red giant when the outer layer of the star gets bigger and his core is shrink. The next stage is a supernova, and the core gets shrink and she gets hotter and thicker, and there is iron in the inside of the star that soaks up the energy. So he shrink, and after he expels all the material from the universe with a big explosion, this is a supernova, and the death of the star. So this explosion we call the supernova, and after the supernova we have the 2 ways. A neutron star is a possibility. It's the leftovers of the material of the star that can be another star, a very small star, formed only by neutrons. That is a small star that could be in this way after forever. And the other possibility is the 6th stage, the black holes that we study in the class. And if the star was more than 8 times bigger than Sun, the leftovers can be a black hole, can transform in a black hole. So it's the end of the very large star. So I need this. I sketch about this. It's easier to understand. So here we have the nebula. The nebula is the first of the third stage of the star, and it's a cloud of gas and dust. After we have the next star, that is a big star, it's a trio star. That is the stages that we can see on the sky. After billions of years, this star could be a red giant. So it's the drop, but it's red, and his core is very shrink. So there are 2 ways. I explain on the shrink, on the cycle, because it could be a supernova if the star is a big star, or if it's a small star, she becomes a white dwarf. Only to know, the white dwarf is a small star composed of electron degenerate matter after the red giant. It's very dense like Sun, and its volume is like the Earth, the size of the white dwarfs, like the Earth. And his fusion, I will explain about the fusion inside the stars. It's only until the iron in the chemical elements in this kind of stars. The supernova, no, the supernova is all other elements. So the red giant, so it could be a white star if it was a small star, or big stars become a supernova. That explains the biggest explosion that leftovers could be a neutron star, small stars without they produce this kind of elements, or a black hole, and all the leftovers and the gases that exceed of a supernova make a new nebula that starts all over again. Okay. And want to know the importance of the supernova is the nuclear fusion of chemical elements inside the stars. If it's a small star that's being a white dwarf, inside the stars is the fusion of these elements: hydrogen, helium, carbon, oxygen, and iron. Only these ones. And inside the supernova, all other elements after iron. To see it's better, I bring the chemical. It's an element table.
Yes, the element table.
Element table. So inside the star, a small star, that becomes a white dwarf only until the iron. It's number 26. So we can see 1, 2, 3, 4, 5, only until 26. It's produced by a star in a white dwarf. In a supernova, after 26, it's produced by a supernova. All these elements, this no, because it's made by a laboratory.
Right. Yeah, those are made by a. Okay.
But until these elements, it's all that elements are produced by a supernova. So it's because supernova is so important. So supernovas, as far about we say it's supernova, the explosion of a massive star at the end of its life. And it could be stars can end their lives in a supernova or in a white dwarf. When the nuclear fusion occurs, and as in stars, we can only produce hydrogen, helium, carbon, oxygen, and iron, and all the other chemical elements are produced by a supernova. So, the conclusion is that without the stars, we cannot be here because we are formed by chemical elements, and there would be no human life. For this reason, many scientists say that we are children of the stars because we are composed by the elements that are created by the supernova. The end of presentation.
Excellent. Wow, very nice. Awesome. Yes, I have some questions. What was the question? Oh, I was so interested in it, I forgot to write it down. But it was the iron, the one with the iron. You said that white dwarf lives until the iron is used up. Is that what you meant? How long does the white dwarf stay? Forever, or does it stay? What happens to the white dwarf? I can't remember.
I didn't.
Oh, you didn't. Okay, no.
White dwarf so long, yes, but it's a white dwarf. It's like the sun. We could be a supernova in the future.
Okay, that's what I meant. You said it's like the Earth.
The volume.
The size. Okay, that's what I meant. Okay, you said it's like the Earth. I'm like, so it's green and has blue.
No, it's the volume.
It's the size of the Earth.
Yeah, the size of a white Earth. Could be compared to the Earth.
Okay, good. Okay, I think that's what I wanted to know because that was the only thing I had problem. Excellent, very nice presentation. How did you think you did on this presentation? Tell me something that you thought you did great at. What did you do good at during the presentation? What did you think you did good at? Yeah.
My sketch.
Your sketch? You like your sketch? That's very good because that was made on the computer, right? By a computer, so that's difficult to do to get everything in order. I know it's a lot of formatting. You're like, and you click it and it goes. You're like, you're like, good, stop, right? So little things like that.
And I changed the slide and we changed the color. All
that's right. We go back and do it again. Oh, good.
But it's nice to understand how this cycle works.
Yeah, it's very nice. I like that. What do we call that? That's a flow chart. A flow chart. Okay. Remember we said for visual aids, what kind of visual aids are good? Flow chart for showing systems and sequence of events happen. Excellent. Now, what do you think you would improve next time? What do you think you would do better at next time?
I think I have to memorize more information
Mm-hmm.
because what I said before, it's information.
There's lots of it.
Lots of information. It's a complex thing to memorize. Or it's not my familiar thing.
That's right. It's not your field. You're like,
yeah.
what? Astronomy? What? I'm a lawyer. I thought it was astronomy.
I don't know what is a white dwarf, so I have to memorize.
That's right.
Write something.
Lots of steps, and so I really enjoyed the showing what the star was and the whole life cycle of the star. You had to do that to explain what a supernova was, though. Mm-hmm. So that was good. So what else would you do? What would you do better besides memorizing more? That's the role of your cue cards, I think, to do that. Yeah. And you did fairly well there.
Yeah.
Now, were you reading word for word anywhere?
Yeah, it's not nice to read the word for word.
Yeah, not because we can read that, right?
Yeah.
And you can if you're saying the same words, we're like, wow. And not only were you reading it, but you were looking at the presentation and reading it, right? So next time, when you're up on a presentation, you got it here, right? You don't have to review back to here ever, right? You can just, right from here, you can read your words that are there. You've got those keywords there. Trying not to, but then, again, instead of having the whole words back and forth, just the key words, and then on your PowerPoint, those regular words that are going to fill in, instead of having the whole word written out, right? Yeah. That I think that's different.
It's more difficult for me, so I have to.
No, that's good. No, this is your first time doing it, and because it is a new topic, you only have like 3 days really. Realistically, Monday, Tuesday, Wednesday, you're not really getting into it. So Wednesday night, Thursday night, you're working on it. And it's basically 2.5 days that you're actually getting the knowledge. You're like, oh, this is not my major. What am I doing here? One other thing I would, one thing, getting the people at the introduction. I had a great presentation. The conclusion that I said we were going to focus on was great, but we missed something in the introduction. What do you think you missed in the introduction?
To explain better what I'm talking about.
No. Your thesis statement was good. You said I'm going to talk about supernovas. Getting attention. The attention getter. Because you went right into it. I was like, oh,
I forgot to put the question. Oh,
what would you...
question. It's how about we know about the universe? How the universe changed our lives?
That's right. Okay, something like that. That was the one thing I
forgot to put.
Okay, so you knew you had to do it, but it was just something like that would have been really drawn me in even more. Okay. But you started right into it. I was like,
it's my mistake.
That's the only other critique I would have of that. The conclusion was awesome. You summarized it up beautifully. You had a great sketch that you made on a computer, which is great with the flow chart. It really helped explain to me what happens and where everything was. And I think you did a great job. So very good. Excellent. All right, next talker, next speaker, please.